This is the third game from PrepTest 53. This is a hybrid game where we have both sequencing and grouping elements that we're doing here. We have to sequence 7 variables, S, T, V, W, X, Y, and Z. We also have to group these variables into 2 groups. One is that they either confessed, these are all suspects here, and they either confessed or they didn't confess. And the way we handle that is we have just a 2-tier sequencing board. Down here on this first layer, we're going to put in S, T, V, W, X, Y, and Z. And up top, we're either going to say that you either confessed with a C, or we're going to say in for no confess. So no confession. So let's take a look at our rules. Our first rule just says that T is questioned on day 3, and that's our bottom row right here. So we're going to put the side here, we're just going to put T, we're going to put subscript 3 to represent that, and we're going to put T directly on our diagram on day 3. It's as simple as that. Our next rule says that the suspect questioned on day 4, so that's right here, did not confess. So what we're going to do, we're going to write to the side that 4 is a non-confessor. In our rules here, we're also just going to put an in here on day 4 to represent that. The next rule says that S is questioned after W. S is after W, which means that W is before S. So we know, of course, now that W cannot be in position 7, S cannot be in position 1, and those very basic sequencing rules, of course, apply here. Our next rule says that X and V are both questioned after Z. So Z is before X, and Z is before V. Our next rule says that no suspects confessed after W. So after W is questioned, we will have no C's. We will have no confessions. So we're going to represent that by showing that W cannot be before C. And we're just going to write W before C and put a line through it. So what does this mean? So let's imagine for a moment that if W was in position 5. If W is in position 5, then we now know that both 6 and 7 both have to be both have to be non-confessors, because everything after W has to be in, right? Because after W, you cannot have a C. That's what this rule tells us. So similarly, if we find out, hey, W is in position 6, then we know that 7 is going to have to be a non-confessor. Now, one thing we do know, though, is that W will never be in position 7, because W has to be before S. That's what our third rule tells us. So if W was in position 7, if we did put W here, then where would S go? There would be nowhere for S to go on our diagram, and that's a problem. So we can't put W here in 7, which means that somebody will be after W, at least S. And whoever that is, whoever is after W, even if it's just S, that's going to be a non-confessor. So we know that there will be an in position 7, because there can't be a C here, because W will be before this position. Our next rule says that after T, we have exactly 2 confessions. So what does this mean for our diagram? Well, we know where T is. It's not like T is some elusive variable. T is in position 3. We know that from our very first rule. After T, we're going to have 2 C's. Well, where could they go? Well, that's not very hard, because the only spots that we have open left are 5 and 6. So we're going to put C into both position 5 and position 6, because there has to be these 2 T's. It's not like there's a maximum of 2. There's exactly 2 C's. So how does this rule run into our previous rule about W not being before C? Well, you may be thinking, well, we already figured out that in can't go into position, or that in must go into position 7. And that's true, but there's more here, because W cannot come before position C. So that means that W can't be in 4. It also means that W can't be in 5, because W then would have to be in front of C here in 6. Now that we know there's a C in 6, then we know that W has to be in either position 6 or 7. Otherwise, W would be in front of C, and we can't have that. Of course, we already know that W can't go in position 7. So we know W can't be in 1, 2, 3, 4, 5, just because of the fact that it can't be before C. We also know W can't be in 7, because W has to be before S, which means that W must be in position 6. We get to infer that now, that W is in position 6. And since W is before S, that only leaves one position left for S. S is in position 7. So let's take a look at our questions. The first question is just a global could be true question. So let's just scan through our answer choices and see if there's anything here that is obviously something that could be true, or anything that we can eliminate that obviously cannot be true. So answer A tells us that x is on 1, that we have x on 1. This obviously cannot be the case. Looking at our third rule here with z in front of both x and v, if you understand how leaders and followers work in sequencing, then you know that if z is before x, then x cannot be in position 1. So A is just automatically out of here. That's no good. B says that V is on day 2. And that looks like it could be true, right? That there's nothing in our rules here that would immediately eliminate that. So we're going to keep B for now and look at our other answers. Answer C says Z is on day 4. Well, once again, we know that can't be the case just by taking a look at our rule here. Z has to be in front of both X and V. Well, where would X and V go? So if this is confusing to you, just imagine for a moment that Z is on day 4. Now you have to place X and V somewhere. Well, we already know that W and S are on 6 and 7. So one of them would presumably go here in 5, maybe X. Well, now where's V going to go? And the same thing happens if we put V here. Let's put V in day 5. Well, now where's X going to go? There's just nowhere for the variable to go. So Z is out of 4. Z has to be in 1 or 2. That's kind of a further inference that we can make, is that Z can't be in positions 4 or 5 just based off this rule. And C then cannot be true. D says that W is on day 5. Well, this is just obviously wrong. We have W on day 6 already. We were able to infer that up front. So D cannot be true. E says that S is on day 6. Once again, we were able to infer up front that S is on day 7. Thus, E cannot be true. S cannot be on day 6. W must be on day 6, and S must be on day 7. Thus, our answer must be B. It's the only remaining answer choice. Question 13 says that if Z is the second confessor, right? If Z is the second to confess. Now, read that carefully, because a lot of people think that just means, oh, Z is the second person to be questioned, but that's not what the question asked us. It says if Z is the second to confess, then what cannot be true? Well, let's just start with the scenario of Z being second to confess. Well, we were able to infer earlier, we talked about how Z has to be in either position 1 or position 2, because Z is before both X and V. So if Z is before X and V, and we know that W is on 6, and S is on 7, and T is on 3, then there's just no room for Z to be in either position 4 or position 5, because there would be nowhere to put X and V. Well, what happens if we put Z in position 1? Well, now Z cannot be the second to confess. There's no one going before Z. So we know Z is not in position 1, which means that Z, the only remaining spot for Z is position 2. So now we know Z is in position 2. We know that 1 is a confessor and that 2 is a confessor. So now Z is the second to confess. And we know here that X and V then are switching off between 4 and 5 because they have to be after Z. So who's going to be in position 1? Who is our only remaining variable? Well, that's Y, who we probably should have known at the beginning is a floater, is a wildcard variable. And Y is going to be here in position 1. So we know Y is confessing here in position 1. Z is confessing in 2, and X and V are switching off between 4 and 5. So we actually don't know if they either confess or don't confess, because we don't know the exact position of either variable. So let's go through our answer choices. A says that T confesses. Well, that's possible. We don't know whether or not T is going to confess, so that's okay. B says that T does not confess. Once again, we just don't know about T. So T could either be C, T could be M. We just have no way to infer that. So both of those could be true. C says that V does not confess. Well, that's possible. V could be in position 4. So that could be true. D says that X does confess. Well, once again, that's possible. If X is in position 5, which it could be, then X could be a confessor. And E says that Y does not confess. Well, that cannot be true, because Y must confess, and therefore E must be our answer here. Question 14 says that if Y is after V, so V is before Y, but then it says that but that Y is before x. So we have v before y before x. And then we're asked what could be true. So what we're going to do here, we want to combine this with the rules that we already have. And we already have that z is before both x and v. So we know that z has to go at the front of this sequencing chain. Z is before v, and thus it is also before x. So z is before v, is before y, is before x. That's what we now know, just by combining our question-specific rule with our rule at the beginning of the game. So z before v, before y, before x, well, these are the only 4 variables that we have for our bottom row. So we know where they're going to go. We know z is going to be in position 1, before v, before y, before x. And we just get to put these 4 straight into those 4 empty spots because we know the order. So let's go through our answer choices. A says v does not confess, and that could be true. We don't know. Maybe v confesses, maybe v doesn't confess. We just don't know. So A looks pretty good here already. Let's go through our other answer choices, though, and see if we can eliminate them. B says that y confesses. Well, we know that can't be true because y is in position 4, and 4 is a non-confessor. So B is wrong. C says that x does not confess. Well, once again, we know that's not true because x is in position 5, and position 5 must confess. So C is wrong. D says that x is on 4. Well, that's just obviously wrong. Y is on 4. And E says that Z is on day 2. No, obviously cannot be true. So A is our answer for question 14. 15 asks us who has to be before t. It wants us to answer who is it that's before variable t. So in other words, who has to go in either position 1 or position 2. And this is something we've already talked about earlier in the game, and that Z has to be in position 1 or position 2. And if you glance through your answers, you'll see that Z is answer E. To briefly recap that again, the reason for that is because Z has to come before both X and V. So the latest that Z can go is position 2. If we were to put Z into 4, there'd be no room for X and V. So Z has to be either 1 or 2, and thus must be before T. Because in either spot, whether Z is in 1 or if Z is in 2, either way, we find that Z is before T. 16 says that X and Y both confess. So we know that X is a confessor and that Y is a confessor. Everything could be true in our list of answers except 1. So essentially we have a cannot be true question. So if X is a confessor and Y is a confessor, then which of the following cannot be true? That's essentially what we're being asked here. So what does that mean? What can we infer from that? Well, my eyes immediately go to position 4, because position 4 now is going to be very limited. Remember that Z, of course, has to go in 1 and 2. And now X and Y, they're both out of 4, right? So Z, X, and Y, these are all variables that are now not allowed in position 4. So who can go in position 4? Who's left over? Because, of course, W and S also can't go in position 4. T, obviously, always out of position 4. So who can go here? And as it turns out, the only variable remaining that could possibly go in position 4 is V. V must be in position 4. So with that inference in mind, let's just take a look at our answer choices. And immediately we look at A, and it says A is that V confesses. And we know that can't be true. Because V is here in position 4, V must be a non-confessor. And A is our answer choice. 17 says that if neither X nor V confess, so X and V are now both non-confessors. This looks very similar to our previous question. We're going to approach it in a very similar way. So X and V, neither one of them confess here, right? So, or neither one of them confess. So they're both ins. So of course my eyes here go straight to position 5. Just like they went to position 4 last time we were looking at confessors. Now I'm saying, so neither one of them, neither X nor V, can go into position 5. So if X can't go into 5, V can't go into 5. And of course, we already know that T, W, S, and Z, of course, as well, has to go in 1 or 2. So Z can't go in position 5. Well, then who can? Who can go into this position? And the answer is Y. That's the only variable left that could possibly go into position 5. So we only have 3 spots remaining, and we know that Z has to go before both X and V. Well, now we know that Z is going to be in position 1, and that X and V are going to be switching between positions 2 and positions 4. So our question is asking us which of the following must be true. So we need something here that must be true. Let's take a look at our answer choices. Our first answer says that T confesses. We don't know. We have no idea whether or not T is a confessor. So we don't, it could be true, but it's not something that must be true. So it's our wrong answer. Answer B says that V is on day 2. Well, V could be on day 2, but we don't know that. X could be on day 2 as well. So B is also wrong. Question 3 says that X is on day 4. Well, same thing as B. V could be on day 4 as well. So C must be wrong. And D says that Y confesses. Well, here it is. Because Y has to be on day 5. And day 5 is a confessor day. So Y must confess. And therefore D is our answer.